Well, hello and welcome to my first video. I've been interested in BBC Micro for many years, having had one in the 80s, and saw with great interest about putting an emulator on the new Raspberry Pico. Done some research online, and there's not really a full video for those who are actually just starting from scratch. So this is my video to show you how to start from scratch to get a BBC Micro emulator up and running on a Raspberry Pico. So I tried with Windows without much success. So I'm using my Raspberry Pi 3 Model B, which I already had. I've obviously purchased the Pico board, along with the Pico Demo VGA board to give the connections I need. So the one thing you need to do to your Pico Demo board, so that you can connect the USB TTL adapter, is to solder in a header. So you can connect onto GP20 and 21 and 0 volts. So to prepare the board, you need to cut the gold tracks between GP21 and SDD2 and between GP20 and SDD1, which will disable the SD card slot. By soldering in a 2x3 way header, you can just put jumpers across to reinstate the card should you need it. But for this application, we need to then connect links from GP20 and 21 to our USB TTL board. We have the USB to TTL board, which I've already connected the black wire 0 volts to the bottom, and then we have the green and the blue for the data transfer. One thing to remember with the USB to TTL converter is that you must have it set in the 3.3 volt position, which in this picture you can see the jumper is on the lower 2 pins. It is marked on the silk screen of the circuit board just to confirm it. So the TTL board connects onto the main demo board with the black on the bottom, the green onto GP20 and the blue onto GP21, like so. Now the TTL actually has a mini USB, not micro, so you'll need a mini USB cable, which will give the data transfer from that board to your Pi. You will also need a micro USB to give the data to the Pico board, so you can send the data to program it and power it as well. Also using a standard SD card to program up, which I'll show you how to program up shortly, just to Kensington 32 gig. If you use anything less than 16 gig, you will get problems when you do the full update on your Raspberry Pi. It tends to hang on certain updates, so Wolfram will crash the Pi. So always make sure you get at least 16. I've got 32. I've just got the adapter just so I can plug it into the PC just to program the software. Also have standard audio cable which I can plug into my speakers, and you use the DAC audio output on the board, not the PWM socket. I'm also using Logitech keyboard and mouse, which are both wireless, so I've already plugged in their dongles there, and there's the keyboard and mouse, nothing special. Also we have monitor. Fortunately I have a monitor which has both VGA connection, which will be ideal for the Pico, and DVI HDMI, which is ideal for the Pi. So I can display the Pi and at the touch of a button can move across to the Pico. So we'll start by downloading the latest operating system for our Raspberry Pi. RaspberryPi.com /software /operating-systems. Scroll down to the latest operating system. Save that to the desktop. Now we'll also need a piece of software called Rufus. That's rufus.ie/en, and that will enable us to install the operating system on our SD card. So download the latest version, save that. That's a lot smaller. So now we just wait for the operating system to download. So we finished downloading the zip file with the operating system, so we'll extract that to the desktop. So now we can run Rufus. It's already found my 32 gig SD card. Remember, use at least 16 gig or you'll have problems, particularly with updating Wolfram that tends to crash the Pi if it's a too small SD card. So we'll now select the operating system image and already start that. Usual warnings, yes and yes. So that'll now produce our operating system SD card. So now Rufus has finished making our SD card, we can take that out of the PC and head across to the Pi. So now we're ready to start up the Pi. Insert the SD card. Then we have the HDMI cable, power cable for the Pi, and then we have the VGA cable for the Pico. Then we have the mini USB which goes into our TTL board. Don't need to connect that up to the Pi yet. And then we have the power cable for the Pico. I'll pop that into the Pi, but again, don't need to connect that up yet. So there's the full setup, all ready to power up the Pi. Right, so now we can carry on with the startup. Set it as you wish. And change the password if you wish. Go for a high security one. I'm not using Wi-Fi. I don't want to update the software on the desktop. I'll do that in command. Load up the terminal, and then we do the two important commands: sudo apt-get update. And now we need to upgrade. I use the up key because it brings the previous line back, and change that to upgrade. Now this will take some time. I'm running with a reasonable network, but it'll still probably take an hour and a half or so. Get the odd question which we need to answer, but other than that, just leave it to do its thing. So while we're waiting for the Pi to upgrade, we'll have a look at Graham's information that he's put with his distribution for the emulator software to run on the Pico. So these are the files which you'll be downloading to the Pi a little later, and there's various bits of information to assist in getting the machine software running. So it mentions about the keyboard layout, which is different on the BBC, the RP 2040 version, which is what we're using, and basic information on how to build, which I'll run through when we get the Pico running, and other bits of information well worth a read. Right, so now we've done a full update, we can just reboot just to make sure everything's good. So now we can start to program the Pico, so we'll get all the software we need. Start by making a directory and going into it. Then we need to get the software we need, so start with the software development kit. And then the extras. And then the examples. And finally the playground. So now we can download the actual software for the Pico, the actual emulator, which is actually from Graham. So now there's a couple of bits we need to do to the software we've just downloaded. So we start with Pico SDK, go into that directory and update it. And then to the extras. Same again. And finally, there's one extra bit of information that you'll need to build, which is the ARM directory. So you need to install this version, gcc arm none eabi. Yes to continue. Right, so that's everything we need. So we'll just reboot to make sure everything's configured correctly. Right, so now we're ready to make the build to go onto the Pico. There's one more piece of software we need to install, is the CMake. Right, so finally we can start doing the build. So into our B-em directory and make a build directory. And then do the CMake. That's written the build files, so now we just need to complete the make. Make J6, and that will do the final compiling, which again takes a few minutes. Right, so that's finished the build of that. So now we need to install the software for the keyboard handler, which will allow the keyboard you're using on your Raspberry Pi to send its controls to the Pico. We need another application library to be installed first, so sudo apt-get install lib sdl2 rsdev. and then we can download the software we need for the event handler. So we need Pico, git clone, it's another Kilo Graham one. Make the build directory. And this time it's just cmake ... followed by make. Right, so we've now got all the software installed that we need. So now we just need to connect the Pico to the USB cable. So press and hold the button, insert the USB cable and release the button. There we go. Removable medium has been detected, so we can open File Manager. So we open the second File Manager window and we navigate to Pico, B-em, Build, src, Pico, and then we find the file beeb1080p.uf2 and we drag that across to the Pico. So now that software has been installed on the Pico, we just need to power up our keyboard forwarder, and then we go back to command prompt and we run the event forwarder /sdl event forward, and we put the USB file there. We should now find, if we switch the monitor to the analog input, we have a BBC Basic. So if we do Shift F11, it gives us the opportunity to change the disk. At the moment we have just Welcome and 2048, but if we adjust the text file we can have different disks. Escape to get out of that, and then break is Shift F12, which will boot up that disk, and we have the 2048 game for us to play. Well, I hope you found this video helpful and you've been able to install the BBC emulator on your Raspberry Pico. You'll find all the links you need in the description below, along with all the typing for you to cut and paste if you so desire. Stay tuned, as I'll be uploading another video shortly showing you how to change disk images and include those in the build. If you enjoyed the video, please give it a like and don't forget to subscribe so you can catch my next video. Thanks for watching. Bye for now.